Hello, I'm Valdemar from Masaryk University in the Czech Republic. I'm going to present our paper about a tool set for collecting shell commands from hands-on training. The scope of our work is practical classes on cybersecurity, operating systems or networking, in which the students use Linux command line tools. While this is a pre-pandemic photo, everything I'm going to talk about works for both in-person and remote classes. Our paper focuses on collecting and analyzing command line data. These data allow us to understand how students progress and where they make mistakes so that we can help students learn. In a broader sense, this is the goal of two related research areas: educational data mining and learning analytics. However, few learning environments support an efficient collection of the command line logs, and setting up an infrastructure for this purpose is challenging. Therefore, we demonstrate the value of an open source logging toolset we created to help engineering and computing educators. We will focus on two aspects: the toolset design and its evaluation in actual classes. Compared to basic solutions, such as shell history files, the toolset's novelty and added value are threefold. First, its configuration is automated so that it can be easily used in classes on different topics. Second, it collects metadata about the command execution, such as a timestamp, hostname, and IP address. Third, all data are instantly forwarded to central storage in a unified, semi-structured format. This enables automated data processing, both in real time and post hoc, to enhance the instructor's understanding of student actions. Let's look at how the toolset works conceptually. In a typical class, a student works in a learning environment called a sandbox. The sandbox contains several interconnected virtual machines which allow the student to practice cybersecurity, operating systems, or networking. Many students can work in parallel with their own identical copies of the sandbox, since each is isolated from one another. When instructors prepare the sandbox before the class, they can deploy our logging toolset, which automatically configures the machines to collect the shell commands. Every time a student submits a command on a Linux host, it is stored on that host using the syslog protocol. The log is then instantly forwarded to a syslog server of the sandbox. Finally, the log is securely forwarded to a central storage in JSON, a semi-structured text-based format. The instructor can access the data continuously in real time or after the training. And the best part is, the logging works uniformly on all machines in all sandboxes. For example, suppose that a student submits a command nmap with the help option. This is the corresponding log record stored in the JSON format. We collect the entire command, including all arguments. All inputs are timestamped and identify the host and sandbox in which the command was executed. We also collect metadata, such as the working directory and type of the command. Finally, to protect the student's privacy, no personally identifiable information is collected. We evaluated the toolset with 50 students in authentic teaching contexts. Most of them were university students, but the sample also included high school students and professional learners. The 50 students were split among 4 training sessions, each of which lasted about 2 hours. We tested the toolset deployment in 2 interactive learning environments: Kaipo CyberRange Platform and Cyber Sandbox Creator, which are detailed in our other paper at this year's FIE conference. The students connected to an interactive learning environment, which hosted their sandbox, and solved cybersecurity tasks in the Linux command line. The students used tools such as Nmap for network scanning, Metasploit for vulnerability exploitation, SSH for secure remote connection, and so on. More information about teaching these skills is available in our previous paper linked from the slides. While the students solved the cybersecurity tasks, our logging toolset automatically collected more than 4,000 JSON log records, such as the one you've seen previously. We implemented Python scripts for automated processing of these data, which helped us find 3 types of insights: commonly executed commands and their argument combinations, the actions performed at the beginning of the training, and timing information. 2 cybersecurity instructors interpreted the results of the automated analysis. They focused on finding insights into the learning processes of students. Here is a brief overview of the results. First, when analyzing the executed commands, we discovered common approaches of students, which included various mistakes. For example, students attempted to run a network scan without providing a target, or executed the steps of an exploit in the wrong order. Instructors can use these insights to provide targeted feedback to students, such as correcting misconceptions. Second, when analyzing the actions performed at the beginning of the training, we discovered students who either set off to a good start or displayed off-task behavior, such as using tools unrelated to the first task. An instructor equipped with this information during the class can intervene early to provide directions to students. Finally, analyzing the timing information can indicate the motivation or skill level of students. For example, long idle periods can mean disengagement or lack of knowledge. Instructors can use these insights for student assessment, which is an essential part of the learning process. To conclude, instructors in traditional classes must look at students' computer screens to gain classroom awareness. This approach does not scale and becomes difficult for remote classes. We presented a technical innovation for teaching, which focuses on logging command line usage. Our approach works independently of teaching content and enables a better understanding of how students learn. Moreover, collecting in-depth data opens many possibilities for future work in educational data mining and learning analytics. The outputs of this research are publicly available. You are welcome to read the paper and access these slides. Supplementary materials include 4 contributions. The first is the logging toolset itself, which can be deployed in various interactive learning environments. The second is an example of cybersecurity training. It includes a sandbox provisioned with the logging and tasks that can be practiced in the sandbox. Educators can use it to familiarize themselves with the toolset. The third are the data collected for this research and analyzed in the paper. And the fourth are analytical tools for processing the data. These contributions can be used by instructors, researchers, and developers of learning environments. If you are interested, subscribe to my Google Scholar profile to receive notifications about the follow-up papers. Currently, we have a journal article under review that documents the dataset of more than 13,000 commands collected with our toolset. The dataset will be freely available for research purposes, such as evaluating machine learning models. Thank you for watching this video. Feel free to email me if you have any questions or comments. Have a good day!